Hey everyone, I'm back with another video, and this is actually going to be the last one in this Python exercises series. So I made it, pretty difficult, but still very, very interesting to code. Now this is a game you all probably know about. It's called Sudoku, and it's basically like a puzzle. So if you don't know the rules, I'm just gonna briefly go over it. Basically, you have to try to fill in these blank spots represented by 0 in this code, and make sure that that number that you filled it in with, that number is not in that row, column, or that 3x3 square. So you have to make sure that it's unique in those places. And so often in Sudoku, at least from in my experience, I always get like stuck, or like I have to like redo everything if I go with one wrong solution. So I decided to code a Sudoku Solver, where basically this program is going to solve any Sudoku grid, as long as, of course, it is solvable. And so basically what we're going to be using is the backtracking algorithm, and backtracking basically involves recursion. So if you don't already know what that is, I suggest that you do, like, find out or research, because that's going to be really important. And backtracking is you're trying to recursively find a solution, and if that solution doesn't work, then you take a step back and then try to take another option, and if that doesn't work, then you go back, and eventually through all these possibilities, you're eventually going to find a solution after going through all the dead ends. And so this is an example of what backtracking looks like, where basically if a solution doesn't exactly work, then we go back and we try to fix it, and eventually through all the combinations, it works. As humans, this would definitely not be a good Sudoku strategy for us. The computers are really strong and fast, so this could definitely work. Now, we're going to begin by defining a matrix, which is a list of lists, and we're going to represent the grid with this. So each row is going to represent a list, and now now what we're going to do is we're going to run this main function here, and we're going to pass in the grid argument to, so it's basically the code is going to solve this grid. All the zeros here, again, they represent blank spots that we have to fill in, and the numbers, of course, represent the numbers. Now, to begin, we're gonna go with the Sudoku Solver function, which is basically gonna try out every combination. It's gonna for every empty square, it's gonna input like a number if it works. So here we're gonna have to check the row, the column, and the square to see if that number is unique, and if it is, then we're gonna put that into the empty square. So this is how we're gonna do it. We're gonna put two for loops, nested for loop. So for row in range 9, and for column in range 9. So we're basically indexing the matrix with two for loops, one for the row and one for the columns. Now, if grid, row, column, so we're going to index the grid and see if that specific square is empty. Now, if it is, then what we're going to do is we're basically going to guess a number from 1 to 9 in range 1, 10. That means we're not actually going to count 10, right? That's the stop argument. So from 1, 2, 3, 4, 5, 6, 7, 8, 9, we're going to try all of them, and if any of them satisfy the requirements, so now we're going to call the isValid function. Over here, now this takes in the grid, of course, the row, column, and number. Now what this is going to do is, like I said, you need to make sure that the number you're trying to fill in, it's not redundant, so that number isn't there in that column, in that row, or in that square. So for example, if I take this first one right here in the grid, if I take this 0, and let's say I want to fill it with 2, then I have to make sure that 2 isn't present in its row, its column, or it's 3x3, kind of like it's 3x3 square. So for the row, we're just gonna use some list comprehension here. So for I in range 09, we're going to be checking grid row, and then I to be checking that whole row. And if that number already exists in that row, then we're going to return false because that number is not valid. Same thing with column. And now this is where it gets kind of tricky. If you wanna basically index that 3x3 matrix, like that part of the Sudoku board, then we're gonna have to. So this is basically what the two slashes do, is it divides one number with another, but it only looks at the quotient, not at the remainder. So if column were to be 4, for example, if that number's column, if it's in the 4th column, then we're gonna like use this operator and divide it by 3. So 4 and then 2 slashes 3. So 4 divided by 3 is going to be 1, with the remainder of 1. Here we're going to ignore the remainder and just take that 1 as the quotient. And we're going to multiply that by 3. So using this expression, we can find the beginning of that square. Of that square in that Sudoku board, that 3x3 matrix, we're going to find the beginning column and the beginning row. So for example, if this were to be the 7th column, then 7 divided by 3, that would be 2 with a remainder of 1. We're going to, of course, ignore the remainder. We're just going to take 2 and then times 3. 2 times 3, 6. So that the 6th column would be the beginning of that of that square. Now, we're going to, again, do another nested for loop. And here, basically, we're going to index the grid, and we're going to go through every square, every little square in that 3x3 matrix, and we are going to we're going to check if that number already exists in that 3x3 square. If it does, then again we're going to return false. But if nothing goes wrong, if the row, column, or 3x3 square, if none of them have the exact number, if there's no duplicate in there, then by default we are going to return true. Then going back over here, if that specific number is valid, then we're going to turn that to, and then the scanner iterator. The scanner, it's just it's gonna, like I said, it's gonna input any number from 1. It's gonna input all numbers from 1 to 9 and see which ones work. The first one that works, we're gonna change it to that number. So for example, if 2 were to work here, the number 2, then we would just if we try 1, then that's an error, because that would give us an error because like in normal Sudoku, not only is it in its row, it's also in its column. If you can see 1 right here, 1, and then 1 right here, and it's also in its 3x3 matrix. So 1 can't work. Now let's try 2, and 2 will work. It's not in that row, column, or 3x3 square. So we're just gonna leave it at that. We're gonna change the first element of the first row to 2. That's what we're basically doing over here. Now, once we've done that, we're going to recall the function inside the function. This is called recursion. We're going to call a function inside the definition of it when we're defining a function. So what this is going to do is, if it is valid, right? If it was valid and it got changed to that specific number, then we're going to move on, and we're going to run this whole thing again. And now we're going to check the next square, the next empty square. Because at this time, this would have already become 2, and so the next empty square would be 0. Let me just change this back. This is just like a random Sudoku grid. It's supposed to be solvable, and this program is so we're gonna run that. Now, what if it's not valid, right? Because if that number is valid, if we're gonna scan it, and if it is valid, then we're just gonna run this function again, and it's gonna go back over here. And this part of the code won't even be run. This function, this recursive function, it'll just go all the way back to the beginning, and so this code wouldn't even be executed. But if this is false, if the value of is valid, if this function is valid, returns false for some reason, for either from if it's in the row, if it's in that column, or if it's in that square. If it returns false, then this stuff won't run. But this will run, because in this for loop, if this specific number is not valid, then we're just gonna turn this into 0. So that if it's not valid, or if the Sudoku is stuck, right? If we can't find a solution, maybe if our guesses were like, if I put 2 here, 2 technically works, but we don't know if when we start filling in the other squares, it might be that 2 was supposed to be something else, and that we messed up at the very beginning, so we have to redo everything. Right, that part is gonna be taken care of by this backtracking thing. So we're just gonna change it back to 0, and then we're basically gonna go take a step back, take a step back, take a step back, and it might even go to the initial where we started, and then we're gonna take a different path. Eventually, after we go through all of them, we're gonna find a solution that works for our Sudoku. Now that we're done with this part, doing the actual solving, now I just thought we could do a little bit of formatting to make it look like an actual Sudoku board. So if I were to run this, then as you can see, it has like these dividers, like the dashed lines and the vertical lines too. It makes it look more like a Sudoku code. So we have like our 3x3 squares here. We have our rows, our columns. We can distinguish all of them. Basically, what I'm trying to do here is I'm gonna use the enumerate function for row count, and same thing here for the column count. I'm gonna be adding like a counter next to each iteration, and you'll see why. So for row in grid, so for each row, what we're gonna be doing is after every 3 rows, we're gonna be adding this divider. Every 3 rows. So at the beginning, we have one. That's kind of an exception. Then 1, 2, 3. 3 rows, right? And then this is gonna be our divider. 1, 2, 3 again. So basically, if the row count, as we're iterating through the grid, we're also gonna be keeping count of which number, like what the row's number is, and if it's the 0th row, the 3rd row, or the 0th index, 3rd index, or 6th index, then right before them we're gonna add a divider. So like right before the 0th index, right before the 1st row, we're gonna add a divider like that. Same thing with the column. After every 3 columns, we're gonna add a divider. So like 1, 2, 3, 1, 2, 3, these numbers, then we're gonna add a divider. So basically this is just formatting, just to make it look more neat, and also like more like a Sudoku grid. Now finally, this function, this is all like, we're defining the functions, so nothing is actually going on here. We need to call the function to have action going on. So anyway, we have this Sudoku puzzle, and we have solved it using this code, and we can find the solution right here. So yeah, that was it. I hope you enjoyed it. And so, again, I said that this is the last video in the series. I will be starting a new series. I still have to decide what that's going to be about, but I will let you know soon. So, but yeah, that was the video. I hope you liked it. Don't forget to like, subscribe, and share the video with all of your friends. That was it for this one, and I will see you in the next one.